All right, let's look at negative exponents and reciprocals now. And this is, again, a rule. And this rule is on your formula sheet, just knowing how to use it and what it means. So when I have a negative exponent, then x to the negative n is the reciprocal of x to the n. So let's look at an example first. 2 to the negative 2. Let's just put that in our calculator. 2 to the exponent negative 2. And it tells me that is 0.25. Well, 0.25, I can write that as a fraction. It's a fraction that is 1 over 4. Well, 1 over 4, I know that is 1 over 2 squared. That's what this means. X to the negative n, x to the negative 2 is the same as 1 over x to the n, 1 over 2 squared. But it is also the reciprocal. That becomes interesting when we're dealing with a fractional base here. I'm taking the reciprocal. It's not just 1 over it. I can take the reciprocal. So for b, instead of negative 3 over 4 to the negative 3, it could be negative 4 over 3 to the 3. And that's how I'd write it with a positive exponent. And now I'm going to have here, my negative stays, this 3, because outside of the brackets, it goes to everything inside the brackets. So you're going to have 4 cubed over 3 cubed, which is going to give me negative, well, 4 to the power of 3 is 64, and 3 to the power of 3 is 27. So I have negative 64 over 27 as my answer. And I could write that as my approximate decimal. And that's negative 2.37. And let's just make sure if I put this in that I'm getting that same number. So negative 3 over 4 in brackets to the exponent of negative 3. Yep, indeed, negative 2.37, exact same number. So that is sort of what I need to do here. Okay, if I've got a decimal to a negative exponent, I can write 0.3 as 3 over 10 to the negative 4, and I take the reciprocal, 10 over 3 to the positive 4, and I end up with 10 to the 4 over 3 to the 4. Well, 10 to the 4 is 10 with 4 zeros. And 3 to the 4 is 81, which is going to give me approximately 123.456. And if I just put it in 0.3 to the exponent of negative 4, I get that exact same number. So that would be my answers here. All right, so evaluate each power without using a calculator. So this is saying using this law, showing these steps that I did above. So 8 to the negative 2 over 3. So first let's deal with 8 to the 2 over 3. And it's negative, so I'm going to leave my negative 2 in there. So this is going to be, I should write that 3 smaller, because it's the cubed root, not 3 times. Cubed root of 8 to the negative 2. So I got the cubed root. My negative sign means I go 1 over 8, but don't lose that 2. 1 over 8 is squared. Okay, so cubed root of 8, I know that is 2. So I have 1 over 2 squared. 1 over, that becomes 1 over 2 to the exponent of 2, 1 over 4. So 0.25. And let's check that on our calculator. And indeed, we are golden. We are good to go. All right, so we're looking at this question. There's actually one typo that I want you to change. This negative sign should not be here. So we should only have the negative sign in the exponent. It should not be, what's happening here? Sorry, it should not be in the answer here. So this here should be positive. All right, so it's not negative. Change that in your books as well, because that is a bit of a typo. So this is a positive 9 over 16 to the negative 3 over 2. Okay, so let's deal with this in steps. So I have here, let's deal with my negative sign. That is going to be 16 over 9. I take the reciprocal, the 3 over 2. All right, now let's deal with our denominator first. So that means that I have the square root, let's do it all, the square root of 16 over 9 to the exponent of 3 still. Let's work with the square root, because both 16 and 9 are perfect square numbers. So I have here the square root of 16 over the square root of 9, all to the exponent of 3. Well, the square root of 16 is 4. The square root of 9 is 3. And I have the cubed root of this. So I would now need to take 4 to the exponent of 3 and 3 to the exponent of 3. And I would get 64 over 27. And that is good enough. That could be my answer for this question here. Again, we put this in our calculator, double check we're getting the right answer, and that's it. All right, so now we've got our word problem here. So paleontologists used measurements from fossilized dinosaur tracks and this funky formula to estimate the speed at which the dinosaur traveled. So in the formula, v is the speed, just like in physics, in meters per second. S is the distance between the successive footprints of the same foot, and F is the foot length in meters. Use the measurements in the diagram to estimate the speed of the dinosaur. Okay, so let's see what we know here. So from the very tip of this foot to the tip of it again is S. You can see here we're given from the tip to the tip as 1 meter. So S is 1 meter. And our foot length is 0.25 meters. So don't be a hero, a question like this. Let your calculator have its day. We are going to use our calculator. Right, don't try to do this without it. The calculator, that's all you need. So 0.155. S, I substitute in 1 to the 5 over 3. F, 0.25 to the negative 7 over 6. Don't worry about trying to do this in your head. Use your calculator, and we are going to get 0.155. Let's go with brackets 1 to the exponent of 5 over 3. Let's bracket again my 0.25 to the negative 7 over 6. Again, know your calculator here. Make sure you are have the fractional exponent showing up, the negative exponent, that's all working properly. And we get a speed 0.781151, etc. And let's just round to 2 decimal places. So my speed is 0.78 meters per second. So I'm going to write that here too. So speed of dinosaur is approximately 0.78 meters per second. All right, and that's it. So again, you have this law on your formula sheet, so make sure you are using that. You just need to know how and when to apply it. All right, so I got practice for you to do. Do your practice and let me know if you have any questions. Keep up the good work.